Welcome to this tutorial on building a battery pack model using the Battery Builder app in MATLAB Simscape. In this session, we will start with a single cell, then move step by step to create a complete pack of 14.8 volt and 81 ampere hour capacity. This structured approach will help you understand cell modeling, parallel assemblies, modules, and packs along with thermal modeling options. Let's begin with creating a single cell of 27 ampere hour capacity using pouch geometry. First of all, we have to open the MATLAB and go to apps tab. In the apps tab, you'll be having varieties of apps. Under the Simscape, we have to click on the battery builder app to work with the battery builder. That is, to create the battery, we use this application. Or you can also search in the search bar, that is battery, where you will be finding the battery builder app. Or otherwise, you can also open the app by typing the command, that is battery builder, which is case sensitive sentence, in the command window. Once you type and press the enter button, you will be getting the window like this. That is the battery builder app. Here we will be having battery builder and battery chart, two tabs. The battery builder, where we can configure the batteries from cells to pack, and in the battery chart we can just decide that is X label, Y label, Z label, and then color. We can change the color and we can change the style of the text and width of the battery line, etc. we can change. First of all, we'll in the battery browser, that is, this is the battery browser. Okay, in the battery browser we have to select the new cell. Okay, we have to create the new cell. Once we create the new cell, it will take some time. A new cell will be created, and the 3D view will be shown like this. And in the cell properties, go to geometry section. Under the geometry section, you have to choose pouch, or you can choose any type of geometry, pouch, prismatic, or cylindrical. Here I am choosing pouch, and I am changing the length to 0.3. These are all my own specifications. You can also have your own specification or own design of configuration. And I'm having the height, that is the height of the batteries around 0.1. I am selecting, and then the tab location is opposed. And in the property section, that is the cell property section, I am changing the capacity to 27 Ah. Now click on apply. Once you click on apply, it will take some time to change the settings. Okay, now it is applied. Once the configuration is applied, the system, that is the 3D view, will be displayed like this. Okay, here we have created a single cell, and now we have to export cell to workspace. This we have to click on the export. Under the export, we will be having export to workspace. Once you export to the workspace, come to the export section, you will be having that is a database is created in the workspace section. Okay, now the step 2. Next, we will be enable temperature dependence, so the model captures thermal effects. So just in the cell model options, this is the cell model option. Under the cell model option, just in the T dependence, make it as yes. Before it will be set as no. Now we have to convert it into yes. Next, set the thermal port model. At last, thermal port, convert it into model. Now click apply. Now the configuration is applied. Once again, press on click the export and export to workspace. Whenever we export the data, it will be stored in the workspace. Okay, that is new cell with the preset configuration, and the new cell 1 with the temperature configuration. Now this allows us to later connect thermal mass and model ambient temperature effects. Now the third step is to increase the capacity. We will connect 3 such cells in parallel. This gives us 81 Ah total capacity. Okay. Therefore, in the create section, select the parallel assembly. Once you select, click the select button in the parallel assembly properties. That is, here we will be having the select button. In the select button, choose new cell and click OK and set the number of parallel cells. Okay, here we will be having number of parallel cells that has to be selected as 3 to make 81 Ah total capacity. Now apply, and here we can see the 3 cells, parallel cells, and now export to workspace. For each step we have to export the data since it can be stored. And the next step is, now let's connect 2 of these parallel assemblies in series. This doubles the voltage and gives us 7.4 volt. Okay. Now in the create section, create the module. Once the module is created, we have to select the new parallel assembly. Okay. We have to select the new parallel assembly. Click on the new parallel assembly and click OK, and it is selected, and set the number of series assemblies to number 2. Now to attain the values 7.4 volt, and then the interparallel assembly gap, here I am taking it as 0.04 and click on apply. The structure will be like this, the configuration will be like this, and now export to workspace. The next step is, now this modules now has a rating of 81 Ah and 7.4 volt. The next two modules can be simulated at different levels of detail. By default, it uses lumped resolution, where all cells are considered as one equivalent block. Okay. Now before going to the next step, just hover the mouse over 3D plot. That is, this is the 3D plot. You have to hover the mouse where you will be having show or hide simulation strategy. Just click it. Here you will be having the simulation strategy. This is the simulation strategy. It is representing the simulation strategy. You can also change the color. Okay, here you can also change the color by choosing any of these colors. Okay, the color will be changing. And the next step is, we'll create module assembly. Okay, just let us go to battery builder. Here we'll be having module assembly. Just click on module assembly. Here you will be having, once again you have to select in that you have to check the new module and add. Once you press the add, the new module will be selected, and then press OK. Now apply. Your configuration will be like this, and then now export to workspace. Press OK. Now we reach the final step, that is building the complete pack. By connecting 2 module assemblies in series, we will be getting 14.8 volt and 81 Ah. That is, therefore, just click on that is create new pack. In this, select the new model assembly 2 times. Okay, you have to select the, you have to add 2 times not to reach the capacity, and then OK. Now set the intermodule assembly gap to 0.04. Now in the thermal model options, set the ampere thermal path to cell based thermal resistance. Now apply. Once you apply, the configuration will be almost done. Okay, this is our expected configuration, that is 14.8 volt and 81 Ah. Like this you can configure any for any capacity. Okay, now export. Don't forget to export all the data. Export to workspace. Click on OK. Now our pack is now complete with 14.8 volt and 81 Ah capacity. To use this back in other simulation, we can generate a Simscape library. With the help of this configuration, we can create a library. For that, we have to click on, in the tool strip, click the create library button, and you have to choose the directory where you want to. If you are using in the software, you have to choose the directory. I'm choosing the directory as like this, and select the folder, and you can name the batteries any name you can give, and just create library. The library will be creating. It will take some time. Okay, that is, this library can be used in any simulation as a battery pack. That is in electric vehicle simulation. On the whole, we'll be having the electric vehicle system. In the system, you can use this particular battery pack. That is the designed battery pack, or the configured, the particular configuration we can include from the library. This library can be used in any electric vehicle simulation. That is, this is our own design. That is, this is our own configuration of battery design. Okay, once you created, it will show a generated file. Okay, in the file that where you have selected the directory. Here you can see these files, that is batteries_library.slx and batteries.mat. That mat is nothing but the data. Okay, the values what we have for which we have configured, and the batteries.slx once again. That is individual modules and module assembly and pack. Everything is available here. Okay, once it is created, it will show this like this: created battery library. Click on OK. We can use this, that is by clicking on this SLX file. The SLX file will open. Okay, this is our module, created module. You can see this module. This is our module. This is created by our own self. Okay, and parallel assembly module is also available. Once again, the overall pack is available. That is, there are 2 SLX file. Okay, in the other SLX file will be having new pack, under which will be having 2 parallel module assembly. We are having 2 module assembly 1 and 2, and for each one we no need to just connect or any blocks. By default it will be giving all ports, that is not to measure the cell current and cell voltage, nominal voltage, parallel assembly, SOC, and individual cell SOC. Everything will be, by default it will be connected, and inside the new module assembly we will be having the module, that is the particular module, the cell module. Everything will be represented in a subsystem manner. Okay, the inside the new pack will be having the new model assembly, 2 assemblies. Inside the new model assembly will be having the particular module, the cell. Here also the cell is available. Okay, we can just copy this block and we can utilize it in any other simulation or any other system or any other electric vehicle system we can use. and this library now can be used as a starting point for advanced EV battery system models. Okay, hence in this tutorial we designed a battery pack step by step using the MATLAB Battery Builder app, starting from a single cell and reaching a complete pack with 14.8 volt and 81 Ah capacity. In upcoming videos we will explore thermal modeling, pack performance under different loads, and integration with power converters, etc. we will be seeing. So don't forget to like, share, subscribe. Thank you.